Hello everyone, this is our third walkthrough video. This time we're going to look at cotangent. So we're going to start with our key features here. The first thing that I want to just refresh your memory on is the period. When we deal with period with tangent and cotangent, they do not have the same default period that we see with sine, cosine, secant, and cosecant. Where we start here is we start with pi instead of 2 pi. We're going to divide that value by 1/6 to help find our period. Dividing by 1/6 is the same as multiplying by 6, so our period length here will be 6 pi. Our amplitude is the same as what we would see in any other function. It's the absolute value of the leading coefficient multiplying times the trig function. We don't have a vertical shift here, and we do have a phase shift. We move 1 unit to the right, one pi units to the right, So let's go ahead and set up our horizontal axis here. Now we know that our period is 6 pi, and we need to start our graph, our first period, at pi. This creates a little bit of a situation. We like to have 8 blocks for a period, but if we're shifted pi units and then we have 8 blocks is representing 6 pi, it just gets a little dicey here. So what I'm going to do instead is let 12 blocks equal 1 period. In other words, 1 block will equal pi over 2. So what that'll look like is, let's see, 2 units to the right will get us pi. That's where our graph is kind of officially going to start, right? Because we have that shift as a phase shift. And then I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm just going to recount here. 1, 2, 3, 4, 5, 6. Yeah, that makes sense. So this here will represent our full period. We know that we're going to start at 6 pi and end at 7 pi. Halfway between those values will get us, 4 pi. Halfway between 4 pi and pi is going to be a fraction here. So we'll have 5 pi over 2. 1, 2, 3 here. And halfway between 4 pi and 7 pi is going to be 11 pi over 2. So this is going to give us 1 full period of our cotangent graph. So what I want to focus on here is where our asymptotes are going to show up. With a denominator of sine here, any points that are on our midline, in other words, values where sine would equal 0, will be vertical asymptotes. We don't have any vertical shifts to bother with here. That makes things a little bit easier. But what that means is that we are going to have vertical asymptotes where sine would normally equal 0. And on this particular problem, that would be at pi here. And it would also be at 7 pi. If we want to make sense of this, algebraically, if we take our formula and plug in 7 pi minus pi gets us 6 pi inside the parentheses, right? 6 pi. And then that value is getting multiplied times 1/6. So we're really taking the cotangent of pi, right? There's a lot of, our input here is 7 pi. The cotangent of pi is going to get us our x over y value. And again, our y value at pi on our unit circle is 0. We have transformed this function, right? We have stretched it horizontally. So instead of being at pi, we're actually at 6 pi plus a horizontal shift to 7. But that's where our periods, this period of cotangent will be set up. Now we have to work kind of on in the inner parts of this. And just like with sine or cosine, if we break our period into quarters, that can be very helpful for us. Halfway between our asymptotes, we should be at a midline, right? We should be at the x-intercept here. Why does that make sense? Halfway between these two periods, if we think about the unit circle, you know what, let me pause for a second. Rather than imagining it, we can actually take a look at our unit circle. So here it is. And where our asymptotes show up on the unit circle without transformations for cotangent would be at any values where y equals 0. So we're basically taking this portion of our unit circle and stretching it horizontally as well as vertically on this problem, right? So we're stretching it by 3 vertically and by 6 horizontally, but ultimately what we need to focus on is the structure of the unit circle. What I notice here, halfway between my starting point and the ending point, is this value. My y value here is at a maximum, right? My y value here is 1, but when we talk about cotangent, we really take x over y. So in this case, 0 over 1. In other words, when we're halfway between vertical asymptotes, we have an x-intercept. So halfway between our vertical asymptotes, we are going to plot an x-intercept. The other 2 points we're going to use are related to our 45-degree reference angles. They are related to 45 and 135. The reason we like these particular values for tangent and cotangent is that their absolute value for the x and y coordinates is identical. So for the cotangent of pi over 4, sorry, I didn't really write that, pi over 4, we get 1. And the cotangent of 3 pi over 4, we get -1. Those are going to be nice, easy values to work with, but we'll have to transform them a little bit. So if we focus on this idea of halfway between our 0 and our asymptote, we are going to apply our transformation and plot that point down at -3. So down at so usually on a standard cotangent graph, we would see points that after an asymptote go from positive to 0 to negative. On this particular problem, because of the vertical reflection, that -3 we see out front, the order of things will be reversed. So at the 1/4 mark of our period, in this particular problem, at 5 pi over 2, we're going to plot a minimum, not really a minimum value, a transformed value that would be 1 if there wasn't a vertical stretch, if that makes sense. And then over at 11 pi over 2, we're going to do the same thing. That's everything we need. We're going to connect that with a nice, smooth, almost cubic-looking graph. And there's a period of cotangent. So things to pay attention to with cotangent graphs. The default period of cotangent and tangent is not 2 pi, but pi. So when we are using our b value to find our period, we must divide pi, not 2 pi. Our amplitude, vertical shift, and phase shift, we approach that the very same way. The big thing to focus on as we set up our graph is asymptotes. Periods of cotangent will start and end with asymptotes. When we look at tangent graphs, they tend to have those asymptotes right in the middle. But in this case, they will have vertical asymptotes at the starting and end points of our period. We plot transformations of 45-degree angles, pi over 4 radians, that are transformed in a few ways. In this case, multiplied times -3, that caused a vertical reflection, and the amplitude on the other side, halfway between our 0 and our asymptote, that will be at our amplitude point. Nice work, team.